session, number 5. We had this morning in session 2 an interesting number of projects involving volunteer QA information. And the current session looks more into how data is coming from volunteers and how it is processed, used, and integrated with other data. So as a general information, please, again, but by now you probably know it already from the other sessions, please, if you do not speak, mute yourself, please. Not turn on your video. And if you have questions, you can put them here in the chat, in the general chat of this session. Not in Slack. Slack channel is there also, but for discussions after the session, after the conference. So we will record. We are currently recording already this session, and we make the videos available. So that's basically it. And then I would like to introduce you to our first speaker. That is Jaap-Willem Sjoukema of the Dutch Kadaster. And let's see, Jaap-Willem is already there. I will just give you the presenter mode. And if you can share your screen, Jaap-Willem, and perhaps also your webcam, so that we can see you.
I will try that both. So hopefully you can now see my screen.
Yes,
And
I
I
think
will
we can
add my webcam, so you can see my right now. It's a really interesting view.
Yes. Okay.
So I will start the presentation. Unfortunately, Rob, you still have some kind of tremor in your microphone. So.
Okay. Yeah, I'm afraid I cannot solve that at this moment.
Yeah.
I could go out and in again. I hope I will not disturb your presentation then. But let me try to do that after you finished. Maybe that's the safest way. And then you can start. I will give you a signal when you are 2 minutes before ending, right?
Yes, thank you. Yeah.
Okay. Go ahead.
Yes, well, welcome everyone. I'm Jaap-Willem Sjoukema from the Dutch Kadaster. And well, my message for today will be close the data loop with crowdsourced feedback. And I will try to show you how you can do that in this presentation. So let me first go to how we view open data. Normally we draw like a linear process, which shows like these steps. Like we have a government. The government publishes data on the web. Developers and companies search for that data, integrate it in nice apps and services, and then present it to citizens and businesses. Well, everybody's happy. Data is reused. Developers and companies can add added value, and also citizens and businesses have cool products. What we normally forget in this kind of diagrams is that in reality it isn't a linear process, or it shouldn't be a linear process. That's a better formulation. Many developers and companies also already noticed that, and they made like a feedback loop from those users to the companies back. So you can go to, for example, Google Maps. You have always some kind of little send feedback button beneath in the footer where you can send feedback, but you can also go to OpenStreetMap where you also have some way to well, present feedback to the OpenStreetMap community. And somehow it was always a struggle to get back also from the users, but also from the developers and the companies to the government. So feedback didn't really reach us. So, well, what I'd like to state is we should close that data loop. And crowdsourced feedback can be of high value for open data publishers. So that is, well, actually the way to get free feedback from the wisdom of the crowd. Like Peter also presented in the keynote, the feedback is free, but how you process it is of course not free. But another nice thing is that you can also better understand who your users are and what they want. It's a lot of open data publishers state like, we present our data on the web, it is used, but we don't know who they are and why they use it. Through feedback, you can also better understand why and who your users use your data. And of course, you can also improve the data where the most value is for your users. However, in many cases, we saw that feedback is hindered by frustrating feedback forms. When you fill in that frustrating feedback form, then it disappears in a black hole and you never hear about it again. And feedback is also witnessed by governments as annoying instead of an asset. And also sometimes a concern is raised like, well, if we open up to feedback, that's scary because we have to admit that our data is not always correct. Well, we also went through this learning process as the Dutch Kadaster, and well, once upon a time, we had like, this was our feedback form. So, well, a lot of fields to fill in, and when you can read Dutch, you can even see that the button to the right means go to the next step. Well, that's not really what's really motivating users to provide feedback. And that's why we created the application Improve the Map. We launched it in 2016 for one kind of key register in the Netherlands, which is large-scale topography, shortened to BGT, which makes sense in Dutch. And well, what's a great value of the system is that it enables everyone to give feedback. We also directly distribute that feedback to more than 400 government bodies. That's because of the large-scale topography is also maintained locally by municipalities and other governmental institutions. And well, we extended later on the system with also small-scale topography, which is maintained by the Kadaster itself, and the buildings and addresses register, which is also again maintained by the municipalities. And we also directly send the feedback to them. Well, you can go to it to follow this link, Verbeter de kaart in Dutch, which translates to improve the map. And then you come to this well, website you can also see a screenshot of. And there you can also, well, the feedback is openly accessible and everyone also can provide feedback by, well, putting a marker on the map and fill in a little form. I won't show it right now because we only have 10 minutes. So what was really interesting, so we introduced this system in 2016, so like halfway 2016. So in 2015, we only had those feedback forms you can see. And then we opened it up to everyone through a crowdsourcing system. There you can see that the feedback is really rising. So it's now more or less stabilizes, but well, instead of like 3,500 feedbacks on the building and addresses data, the BAG, well, in 2018 we almost hit 12,000 feedbacks. And also this year we can see that well, we added a little prognosis that again it's going very well with especially the buildings and addresses data, the BAG, and the small scale topography is also growing. What I also always find a very interesting diagram is we have actually a two-phase approach for the BAG feedback. So about the buildings and addresses. So here you can see well, the sources of feedback. So at first we had like three kind of sources. Like we had the form, which is this green line. We had people just emailing us, which is this brown line. We also have an application from the central government, which is called DigiMelding, which is not really well, delivering a lot of feedback. And then we have the orange, well, the orange one is the total. What you can see is that we have, by launching feedback into a viewer, which is another viewer than the improved map viewer, but by allowing people to give feedback there, that we did not only grow in feedback, but also the multitude of sources diminished. So you can see that still, for example, email was an option to give feedback, but almost nobody used it anymore. And what we connected in November 2017, the Bach viewer also to the backend of the feedback system, and since then even the amount of feedback is even higher. And this is explainable by the way that from then on it was also always you can also track and trace your feedback. At the previous first phase of allowing crowdsourcing, you could create it on the map, but you can't really see it anymore. Well, there is always a question about what's the quality of those feedback and what's the quality of VGI.
You have 2 minutes.
Okay.
Yeah.
You made me shocking. Okay, well, that's good to know. I will speed up. Well, the quality overall is very good. So you can see that overall this blue diagram, it's always is most of the feedback is approved, and only 0.4% of the feedback is marked as spam. But did we close the data loop? Well, to some extent, we allowed users to present feedback, but well, we didn't really get those company and developer data. So what we did in 2019 is that we opened up our API to external parties. So with this API, users can directly give feedback and also show feedback in their own application. And we are still developing also an API for governments to connect their software to assess the feedbacks locally. But we published it in 2019. You can see it here. It is the same API where also Improve the Map and the bug viewer is connected to. And to our surprise, one of the first users of this API was OpenStreetMap. OpenStreetMap imports on a regular basis all buildings from the buildings and addresses data. And of course, those buildings change. So what they did was to develop a plugin for the JOSM editor, which is an editor for like a GIS editor for OpenStreetMap. And they directly showed and gave feedback through that API. And well, this process started this year, and we can already see that 7.1% of all feedback is going through that plugin. So did we close the data loop? So yes, we did, but there is still room for improvement. So it's what's always a challenge is to motivate all 400 plus governments to assess the feedback on time. It's also appeared difficult to attract commercial parties to connect to the feedback API. And we also created synergy with the OpenStreetMap community, but it is more like thanks to their proactiveness that this synergy emerges. So because they deliver us feedback, we don't do it all the way around, or we don't compare data with OpenStreetMap. However, we can really see that feedback is flowing better than ever through the system. We can also see that people are motivated to contribute. The feedback is of good quality and also covering all the country, and well, every day there is new feedback delivered. And luckily, there are also first signs that also commercial apps will connect to the API. So we're now, for example, a recreational app for walking through the Netherlands for walking routes is also connected to the API. So that's very welcome. So yes, open data meets VGI. It is a reinforcing data loop, and well, I think we can reinforce it better. But I think these are really cool, nice steps. I'm looking forward to your questions.
Okay, thank you very much, Jaap-Willem, for your interesting presentation. We've seen some of the things that also were kind of introduced earlier this morning by Magdalena. There's a question about users from Sander. So, can users also upload corrected geo information?
No, unfortunately not. So it is really like pinpointing where the error is, and we don't allow yet that people can directly upload like a set of polygons and objects to which we can integrate directly into our data. It's also a bit due to that it's like the key registers have they have to be measured by surveyors or with aerial photography, and that's a bit difficult to integrate directly, but it can of course help data providers. So it is like a point in the horizon we can we like to see.
Okay, thank you. And there is a question from Peter. So you mentioned OpenStreetMap. We're proactive in creating the linkage with Kadaster. So what is it that convinced Kadaster to say yes to OpenStreetMap?
Well, it's more like the other way around. So everyone can give us feedback, and OpenStreetMap, the OpenStreetMap community was really happy to give feedback to us because they also use core data to integrate into the especially on buildings, but also for updating their own maps. And it was like more like from the OpenStreetMap community that they said yes. Well, very cool. There is an API. We would like to connect to it. Then that we invited them or had to enable them more. So the API is open to everyone, and they were the first users. So they are really motivated to contribute. So that's very cool.
Okay, I think we are right on time to go to the next presentation. Thank you very much, Jaap-Willem.
Yes, thank you as well.
And I just wanted to check now with Bettina if my microphone has improved. If yes, then I will stay. Otherwise, I will quickly go out.
Well, for me, I would say you're understandable. It's a little bit bumpy, but given to the fact that you're not presenting for a longer time, I think it is okay.
Okay, good. Thank you. Okay, so yeah, let's then switch on to our second speaker, who is Sander van der Drift from DAT.Mobility, or should I say DAT.Mobility. And I would like to ask Sander to switch on, and I will give him the presenter mode. Let me see. Yeah. Okay. Yeah, Sander. You have presenter mode now, so perhaps if you can share your screen and your webcam, it would be very nice.
Right.
Yeah, I hear you. Yeah. Mm-hmm. See your screen also. Yeah.
Perfect. Well, I got about 10 minutes and 2 projects to present, so I will be very quick.
Okay, good luck.
I would like to show you some examples of our use of volunteer geographic information, and also our collection of geographic information by volunteers. 2 projects. First project is about tourism in Amsterdam, which used to be a big problem. It got way too crowded in Amsterdam. And I had to do a research assignment for my final thesis of the Wageningen University, Geoinformation Science, back in 2015. And I thought, okay, how can I study the patterns of tourists in Amsterdam? And I thought, okay, what is a tourist doing in Amsterdam? Well, a tourist takes photos, obviously. And we have this nice database online like Instagram nowadays. Back in the day, also Flickr, which captures a lot of photos taken by tourists. Many of those photos also have very interesting metadata to process and to study. So I created an harvester that automatically downloaded all the geotagged photos in the Netherlands and stored them in a spatial database, PostGIS. There was one restriction. It was just 1 request per second, so it took me a very long time to gather all those photos. So how did it work? You could search for the photo IDs within certain bounding boxes. That's how the API worked. So I divided the Netherlands in many bounding boxes, and then I started to query for all the IDs that are located within those bounding boxes. It got me a result, photo ID, user ID, and a title. But I needed more information, obviously, for my analysis. So per photo ID, you could query for more information, like the latitude, longitude, user ID, timestamp of the photo, the country of the user, tags, photo URLs, etc. So it took me about 5 weeks to download this big database of geotagged photos before I could start my analysis. And this is how it looks on the map. So you can already see the city of Amsterdam with many photos on top of each other. But it's almost too much to see where the really crowded areas are. So you could, place them on a map, explore them a bit more. So you see some photos in Amsterdam on a map. You could do some cluster analysis. So those are, it's a DB scan cluster method to analyze where the most densely areas are with the many photos. You could also use the metadata of the photo itself to actually distinguish what kind of location it is. So, for example, the tags that are being allocated to the photos, you can use them to say what kind of location it is. You could also place them on a map. So what I tried to do is to create a density map of busy trajectories in Amsterdam. If you use subsequent photos of tourists, you can actually place them in time on a map, and you can actually follow a tourist through a city on a day. And it's interesting, especially if you do it for a large group of people. But it's even more interesting if you can actually relate it to the map itself. What I would like to do was from straight lines to trajectories. So I used OpenStreetMap, another big source of volunteer geoinformation, to see what are the most tourist route in a city. But a tourist normally doesn't take the shortest path, of course. It takes mostly the most beautiful part, or a touristic path. So I used an algorithm to give each link of the network a weight, and the weight is based on the number of photos taken in this area. So here the dark blue areas are locations where a lot of photos were taken, and I used that information to connect it to the link to get some sort of weighting. This is how it looks like. So densely area, dark blue areas have many photos, and light blue areas have less photos. And then I will create an algorithm that mostly choose the trajectory with many photos. I know it's a bit fast, but this is how it looks like at the end. So with this data of 3 million people, those trajectories in Amsterdam were the most touristic trajectories. And it was also compared to counts on the street and expert judgment of people working for the municipality in the tourism sector. This is some more insights. On the right bottom side, you see this map with the big highlights in Amsterdam. You see some temporal patterns that you can distinguish from the data. And on the left top side, you see a map with spatial patterns of locals in the orange dots. They go more to the suburbs and neighborhoods around the city center, while the tourists actually really stay in the city center. So just as one example where I used volunteer geographic information. Another example that I would like to show, well, you see another close-up of the map. You see this tall red column on the bottom left side. That's actually the I Amsterdam statue. That was a very popular statue where a lot of people took a selfie and took photos. It has been removed by now. Another one that I would like to show is the DAT.Mobility panel, also the Nederlands Verplaatsingspanel. It's actually a panel of people that travel around with a smartphone application, which automatically captures all their travel behavior, all their travel patterns. The panel consists of approximately 8,000 volunteers at the moment. And you have this smartphone application that can automatically distinguish what kind of trip the people are making. And it uses actually all the sensors of the mobile phone for obviously GPS, but also the movement of the mobile phone. It compares them to trajectories of OpenStreetMap, to trajectories of public transport, etc., but also the speed and the pattern of the movement to distinguish what kind of mode of transport it is. For example, walking, cycling, car, public transport, etc. And that's very interesting, especially now in Corona times, because we have a lot of traditional sensors that tell a lot about our movement on the streets. For example, we have accounts that say that we have 50% less car traffic on the national highways. We have the public transport chip cards where you use to check in, which say that we have 90% less public transport travelers. That was at the very lowest of the lockdown, and we have empty inner cities. But all those data sources don't really explain what is really happening. So they don't show us where the people that normally used to take a car, where they went. Did they stay at home, or did they 2 minutes?
You have 2 minutes left, Sander.
I'll hurry. Perfect. So they don't really tell the whole story. And if you have this volunteer geographic information of those 8,000 panel members that we have, they do explain the story. So they see that people that would normally take a car are now, for example, using public transport. So this is an animation of people traveling around with this application. On the left side, you see the map of the Netherlands, of course, and on the right side, you see the pattern at the Thursday after the lockdown compared to the pattern what it normally was. So we see less public transport, we see less car use, and we see more people walking during the day and taking a bike. You can get lots of information from it. These are some articles that have been published over the last couple of months, which is really exciting. Also, the national news made an item about it. So that's really nice. These patterns are really useful for policymakers to assess their policies. It's actually being used also by the ministry at the moment. There's also a funny fact that the first 7 Sundays of after the first lockdown, we actually spent more time walking outside than we used the car. And that hasn't been the case since the oil crisis in 1973. So that's an interesting fact. You see some more patterns that you can derive from this data. So patterns over time. You see the morning rush hours that disappeared with the car. You see the morning rush hours and the evening rush hours that disappeared with public transport. And we see also different destinations that people choose to go to. Less people went to the office, of course. Less people went to healthcare locations. So this is really interesting. And we can also see what the public transport travelers, for example, did. So only 40% stayed traveling, and many also changed their mode of transport to the next destination where they had to go to. So they changed to car or walking or cycling. So very quick, in a nutshell, what we do with volunteer geographic information. So thank you.
Thank you, Sander. Really interesting. So there's a compliment from Peter that you have nice visualizations. I don't see a question yet.
The story was a bit quick, so I can imagine a lot of information to.
Okay, I have a question. In the meantime, maybe there could be another one, although we have to watch time also. So in your second, let's say, part of the presentation, you used a panel, which was probably constituted from different, let's say, types of people as a good spread, I suppose.
Yeah, that's correct.
Yeah.
Yeah, we work together with Kantar, which is was formerly TNS Nipo. So it's a big research company in the Netherlands, and they have a panel of approximately 100,000 people. And we approach those people with the question if they want to volunteer in our program to be tracked for research purposes.
Yeah. Okay. And so that was not for the other for the photographs. That was just not. Of course, it was. You had a lot of people, 2 million or so, or 2 million pictures.
Yeah, approximately 3 million people, but the amount of people was less, and also there's more bias in the social media data than we have in our panel data, because with the panel data there's a better spread over the country geographically, and also a better spread over different incomes, different ages, different households, sizes, etc.
Oh yeah, thanks. And Peter has a question. He asks you, given relatively short time since lockdown, what is your approach to gathering the data and doing the analysis? So, do you have lots of manual work?
Well, yeah, the advantage was that we had already, the panel was already in place, so we had already, the system was already running, so that was nice. But a lot of our analysis and a lot of the questions that our clients asked had to be developed during the lockdown and right after the lockdown. So that was a bit stressful and a lot of work, but also sometimes it's good to have a crisis to really quickly develop interesting stuff. So
yeah, right.
it's been useful.
Okay, thanks very much, Sander,